And this is the reaction section. Notice the two precision flow valves here. Those are coming from the previous sections. The flow goes through here up into the reaction chamber. The glycerol output is located at the bottom because of gravitational abilities. And this section here I'd like to draw attention to. This allows us to take a test measurement of the fluid without stopping any of the reaction or taking a hose out or something. We can just take a sample and close it off, and that allows us to look at.
Can you please show the corresponding sections? Sorry for interrupting. You have a picture there where you can show those sections.
Well, there's a picture here, but it's kind of small. So the flow meter is here. This would be the input port. The glycerol comes out down here. And the test section is this small PVC pipe right there. And that allows us to take that output. Now, we were looking at using specific gravities to measure our separation efficiency, because if we know the specific gravity of the input fluids, and then we can measure the output fluids as a ratio of that and determine how much of the fluid is actually truly separated. Because that's what we're really trying to do with the reaction chamber here, is a continuous separation efficiency. All right, and now I will be speaking about data acquisition, which is what I had intended upon working last semester. So this is a continuation of work done then. Data acquisition, overall goals, here's the computer terminal itself. So we were designed to document what was happening in the reactor so we could go back and look at what happened afterwards, determine if we were meeting our requirements or not. The measurement allows us to view system parameters in real time. This is important for controls, obviously. And some of the materials we use to accomplish these are some sensors. We have 2 thermocouples and a flow meter. I have an extra thermocouple here. I'm going to pass around. I'll like show and tell. The data acquisition board that is housed inside of the computer here, and it was programmed using LabVIEW. For purposes, LabVIEW is really good for intuitive block programming, and it works very well with signals and systems, so that's why it's chosen. All right, the sensors, what you have there is a type A thermocouple that we purchased from National Instruments itself, and it is surrounded with fiberglass for heat resistance. The mixing temperature and the oil temperature are the temperatures that we want to get, because we don't want the oil to reach its smoke point where it starts to degrade and break down. And so one thermocouple will be placed next to the immersion heater that's in the oil tank itself to make sure that that temperature is not obtained. The second temperature will be taken at the mixing point, so that would be along the static mixer, exterior to the reaction, and that allows us to determine the temperature that is at the reaction site, because that is important for the mixing of the two, or the actual reaction. The flow rate is measured by a oil flow meter from Omega. We've been working on getting it to run correctly. It has a lot of settings with viscosities and specific gravities, and it's in an error state at the moment, which is strange, so we called the company and we're working on getting it to run how we want it. But I have gotten information from it. We're just trying to straighten it out and get it all to look nice. One of the problems we have, actually, with automating the system in the future would be maintaining the glycerol level. As the state inside of the reactor is continually changing, and the glycerol itself is a very thick fluid substance, so it doesn't flow continually. It builds up and then flows through really fast, breaks away. So it's hard to measure that depth. And so Dr. Parnas, the original maker of this design, himself said that it was very difficult to, balloon measurements, depth measurements, it was very hard to measure that level. They ended up using like a radar system that could do it. But so we didn't tackle that challenge at this time. The data acquisition board that we used is from National Instruments. It's the PCI 6230. It has 8 analog inputs, 2 of which will be used for thermocouples and 1 for the analog flow meter. It was purchased with the intent of making the system controllable in the future from the board. So we have 4 analog outputs and 10 digital channels that facilitate that ability. This one specifically works integrated with the computer motherboard. It's actually housed inside of the computer casing. The virtual instrument that I programmed this semester, a LabVIEW program to collect data as well as control the reaction in the future if those pieces are added. So it has 3 tabs that are designed to be run in succession from the left to the right on startup.